Okay, final project. Before I go to details and other figures, let's take a look at what does it look like. So if I go and run my project, the window will pop off, and as you can see through the camera, um, I basically build in my mind, I was trying to build a camping scene, as you can see, if you can tell. So, I mean, uh, it's definitely not great, not the best, but that's best I can offer. So as you can see, there's a yellow tent on the left side of our camera, and if you go close, right alongside of the camp, there's all the models that I put into and combine with those three desks. There's a box, and those three desks, they are full with models that I found from internet. There's a lot of tools, plate, bucket, things like hammer, scissors, right, axes, and knife. There's also a box, and inside this box there's screwdrivers, something like nails, something like that. Behind all those things, there I put a house model, which is quite cute. It looks like that. So um, I put a giant mirror behind all those game objects, because just want I just want to demonstrate the mirror effect that I bought into my final project. And yeah, that's basically all my project is about. Oh, there's light. I put two spotlight, as you can see right here in the scene, and there's more actually. I believe there's a circular light, which will circular. Yeah, you may not see it clearly, but it's circular around my whole scene element. Uh, the turret and the skybox, they're looking good, I believe. And yeah, that's whole thing of my final project. Now, go into details. First of all, we are required to make pre-made models. So in the model model tools, right, we have all those functions to help us to create the pre-made model. So if we go inside the create unit box, we'll basically create a cube for us, right? The cube, all the pre-made model can be texture and light and have correct normal and textures coordinate if they have. So create unit box with repeated texture on each face. We have create unit box with 6 face texture, which means we now add UV coordinate to our pre-made model. And let's go along. We also create pyramid. Pyramid with repeat texture. We also have the unit sphere is right here. So yeah, that's basically how my pre-made my model tools and alongside with pre-made models. Now jump into our model class. In model class, um, uh, here, so this pointer, this mesh separator pointer will help us, to calculate how many mesh the model has and get each mesh triangles count and triangle offset, because we are my model my model class, excuse me, implement the external model that can read data and from the file converted from FBX model file. So my external models doesn't limit the number of match count, and I extend the mesh separator with an extra constructor function for the pre-made model as right? Um, so let me show you what I mean by that. Uh, Go to the mesh separator and scroll down. As you can see, add a constructor function to precise this situation, and get mesh count this function. If our mesh size is 0, you return 1. Otherwise, you will just return the mesh size. So uh, we call this constructor function that to proceed that pre-made model, since the pre-made model has only one mesh situation. And if we go to the model.cpp, and I believe it's right here. So what we call the constructor function that proceeds the external model read from model file, and it has multiple mesh situation, and we have a render function right here. So now only render one mesh from the model, and this will help us to provide the color or texture for each mesh. Now let's jump into shaders. So my project include 4 shaders. The color select 3D and texture. Uh, Shaders are all the same as we covered in the class. However, my light color shader and texture light shader can shade as many as one direction light, 6 point light, and six. There's 6 point light and 6 spotlight. And let me show you what I mean. If we go to light color shader and right here. Yeah, so I modify the constant buffer in here to include as many as one direction light, 6 point light, and 6 spotlight. And if we go down to here, you can see this part will compute as those 6 point light as follow, and as well as the spotlight, 6 spotlight, as you can see. Now, frogs. I do have a constant buffer that will have right here, right? That will use a constant buffer to pass a frog parameter, and at the bottom. So this section of code will compute the spherical fog with user-provided parameters. So now, as you expect, uh, in my shader color light file, I will have my constant buffer for the frog parameter. And let's go to the shader color, the color light. So the CPP, you can see it should be right here. So, and as well, and we will also have light. So for the point light parameter, it should be specified. Let's see, right here, and for the spot parameter right here. That's a place to demonstrate how I set up my uh, light parameters as well as frog parameters. So now we will update all the global parameters to the shaders in set2 context function. And let me show. So right here, right? So now, texture light shader. We have to set up texture to the light with texture light shading, and so it was set up here with register, and it will do the math. Or the color equals to the ambient plus diffuse plus specular, and as you would expect, we will also have to create constant buffer for passing the frog parameter to texture light shader. And go here, right here. That's what I'm talking about. So right here we have we will set the texture to the texture light shader. Now I guess that's enough for my shaders. Uh, now if we go to model, flat plane model, uh, it it's the same as we covered in the class. It will construct a square with two triangles on the XZ plane centered at our origin, a square of dimension length times lines on the XZ plane center. So in this project, I use the flat plane uh, uh, as a giant mirror to render a mirror itself, and the edge of the mirror as the edge of the mirror that mirror as a flat plane that's slightly behind this mirror. So that's where I'm using the flat plane. Now, Skybox class, as we all know, uh, as we all know, it has its own inward cube model that apply a texture internally. I mean, texture passed in as a pointer parameter and built to size as specified by the user. And so in this project, it's used to render. I found a nice little texture for my skybox. It's a night, as you can see, it's a night environment with a moon in the sky. So if we go details about it, this is a part that I'm talking about. This will create a back inward face for our skybox, and if we go down, this will create a left inward face. It's all in the common, as you can see, the front face, the bottom face, all the faces. And I think that's enough for the skybox. Let's jump to the terrain. Where's my terrain model? Now, for the terrain model, it's a class that will create a terrain plane mesh based on the head map texture for us. Uh, the size of the head map texture is, n times n. If it is n times n, my the terrain plane mesh will has n times n vertices, and I forgot, there's a formula for the number of triangles, I believe. Oh, it's literally right here. So number of triangles is this formula, and so for the field vertices of my terrain mesh, each of the field vertices is incident on 6 faces. The normal of each field vertices is the average of the norm of the 6 incident faces. In this object, obviously, the terrain model is used to render my camping grass ground. So now let's jump into game object. So game object system contains a base class called game object base, and it has a file derived class. So the base class provides some common functions for our graphic object. I mean graphic object. I'm sorry, I was always saying game object. So for example, the set to context class function is the same as set to context function uh, of the model class and the shader class that we covered in the class. Get context get context function, which is still the same as we set to context function of the model class and the shader class that we cover in the class. So something different, set reflection matrix, this function, and get reflection matrix, those two functions are used to set reflection matrix and return reflection matrix when we want to draw the graphic model into a mirror. Set model function is used to set a model's pointer for the graphic, and I believe this function we covered this function in week 8 class. The virtual void render class equals to 0 is used to render the graphic model. This function is covered in week 8 class. as well, I believe. So for the graphic object color, this class and color light class, we use set light function to set the texture for a specific mesh in the graphics model. Uh, for the texture class, we use uh, we would obviously set texture. We use obviously set texture function to set a texture for specify mesh in the graphics model, and for color light and color texture light class, we use set material function to set the three type of lights reflect parameter for a specified mesh in the graphic model. Now, for all the derived class, I mean, uh, graphic object color class, texture, light, mirror class, we use the set word we use set word function to set a word matrix for all the for all basically all the meshes in the graphics model. And my game object mirror class are used to render the mirror effect graphic model. If we go take a closer look of this class, uh, so this class use create mirrored context. It basically create it will create states functions to hold and manage many states like depth substantial state, uh, rasterizing state, and blend state. And if we go up, this class will also use set mirror matrix function to compute the mirror's own reflection matrix. Uh, when we start render function, the mirror so it will start to deal with step two with a single method include preparing for step three and so the the so the complete render function will finish off with step four with a final call to mirror method. So in order to render the mirror effect in my camping scene, I use the black color to clear render target view in uh, where's main app? So I was drawing here. I changed it to black color ground. Back to step four, set a word matrix function call and set the alpha value to 0 in order to get full transparency so that we can only draw everything in mirror only. So now if I go next, um, I draw the mirror reflect object model first, and then our the other normal game object model second. Finally, let me show you some important functions in initial demo and drawing stage. Uh, if I can find them. So, oh, got it. So add a graphic object color light function is mainly used to load the 3D models with only color but no texture. Uh, so add a graphic object texture light is used to load 3D models with textures. And as I go down to the move camera to red Y function and correct right position function are mainly used to ensure that our camera are placed object model can follow the height of the terrain. Keep going. Here we have four functions. They are mainly used to uniformly set the light source parameters and four effect parameters for all shader color light and shader texture light in our DirectX app. I need to emphasize that our camping scene use one direction light, two spotlight, and one of a spotlight will be moving by a circle, as I shown you before, and the 5-point light. And the spotlight does not add, dynamic movement effect temporarily. So I think that's it for my final project. That's all I want to talk about. Thank you.